Hi guys, we are looking at 6-6 today, trapezoids and kites. So we're still in quadrilaterals, the four-sided shapes. These are not considered parallelograms, where both sides are parallel, both opposite sides, and that's because of this pair of sides. Those are definitely not parallel. So trapezoids and then kites we'll look at in just a second. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So on this one, the top and the bottom are parallel, but then the two sides are not. And here's a couple things. If a trapezoid has congruent legs, then it is an isosceles. And actually, let me go back and say these two things on the side are called the legs. And then the two parallel sides are called bases. So that's a base and this is a base. Okay. If a trapezoid has congruent legs, then it is an isosceles triangle. So we've got the two parallel sides. We'll put our little arrowheads on there to say those are parallel. And then if the two legs are congruent, so let me put my little mark on here that they're congruent, the same length, then that's called an isosceles triangle. That's one of those pretty triangle or trapezoids that you see on like a poster or something when they say, here's a trapezoid. That's a classic trapezoid with congruent legs, isosceles. If a trapezoid is isosceles, each pair of base angles is congruent. So again, we've got that perfect little trapezoid. These guys are congruent. That means that these two base angles are also congruent. And these are congruent. Okay, so the two lower base ones are congruent and the two upper base ones are congruent. All right, if a trapezoid has one pair of congruent base angles, then it is isosceles. So they haven't told us that it's isosceles, but we can see that the base angles are congruent. We'll just pick those two. Could have been the top two. Then that means it is, let's do it this way. If we have one like this, then it's isosceles. And the way you mark an isosceles trapezoid is to say that those two sides are congruent. So we can go back and forth. If we know the two sides are the two legs are congruent, then we know the base angles are also congruent. If we know the base angles are congruent, then we know that those two sides are congruent and that it is isosceles. So you got to be able to work it both ways. A trapezoid is isosceles if and only if its diagonals are congruent. So let's draw that. We know the diagonals connect the vertices. So here's one diagonal, and here's the other. Ooh, mine got squiggly. Okay. So if it's a trapezoid, then these diagonals are congruent. They're the same length. But also, if you have a trapezoid and the diagonals are congruent, then you know it's an isosceles trapezoid. So you can go both directions with that. So actually, let's mark this. Those outside legs are congruent on an isosceles trapezoid. Okay, so that's a couple things about that classic pretty trapezoid, the isosceles. Example 1 says, find each measure. They want to know the measure of angle D, so this guy down here. And they gave us A. So a couple things you got to remember as you work on these. It's isosceles because we can tell that these two sides are exactly the same and these two sides are parallel. That means angle A and angle B match. They're congruent. And that would mean that angle C and angle D are congruent. One thing I think we didn't say is that these two angles together are supplementary. So 125 up here, and then this one, whatever would be the other, when you add them together, what would it make 180? Remember that a quadrilateral has 360 degrees altogether. And since these two guys match, they're congruent, and these two guys match, then that means we can split that 360 exactly in half. And there would be 180 degrees on this side and 180 degrees on that side. That's because everything's congruent side to side. So if it's 180 over here, 180, we'll subtract 125 to find out what's left for C. And 125, so that is 55 is left for C, measure of angle C. But then we wanted D. So this guy's 55. And the cool thing then is that we know those are both congruent. So angle D must also be 55 degrees. I'm going to say also, just so that when I'm looking back at it, I'll remember that I found C, but then I know D is the same thing. Okay. All right. So we got 360 for a quadrilateral. And since these guys match, we know there's exactly 180 for these two together. Now we can't split it this way and say there's 180 up here and down here because these guys don't match at all. So it doesn't work splitting the 360 the other direction. Okay, let's look at B. This says if VT, so that's this piece right here, is 4.6 and TX is 4, so 4.6 and 4, find WY. That's a completely different diagonal, isn't it? Okay, but what do we know about the diagonals? That was this guy. They are congruent on an isosceles trapezoid. And this is an isosceles trapezoid. So the entire distance of this diagonal is congruent to the entire distance of this diagonal. Let's find this one first, V to X, 4.6 plus 4, 8.6. And then that means WY is 8.6 also. Since they are congruent, it has to be the same. All right, I'm going to have you pause your video and try these two problems and then come back and we'll check. All right, let's see. This says find the measure of angle L. So they gave us K and we're looking for L. And I remember that these two are congruent, so this is 40, and these must be the same, so I know there's 180 degrees over here. Let me subtract out the 40 and see what's left. 140 for angle L. So the measure of angle L, 140 degrees. Is that what you got? Yes. Okay, and then this one says, if EP is 3.5 and PG is 2.2, find HF. Okay, so we're lining up our opposite diagonals again. This guy, total, EG is 3.5 plus 2.2, which is 5.7. And if that diagonal is 5.7, I know HF is 5.7 also, because they are congruent. Okay. All right, so isosceles trapezoids. Let's turn the page over. The other thing that we're going to do with isosceles or with trapezoids is work on that mid-segment. So if you have a trapezoid like this guy, and you draw a line exactly in the middle, halfway between the top base and the bottom base. We call that the mid-segment. The mid-segment of a trapezoid is parallel to each base, and then to find the distance of that mid-segment all the way across, it is 1/2 times the sum of the bases. Okay, and hopefully that doesn't sound too strange. The sum, so we add the two bases together and then we divide it in half. It's like taking the average of the two bases. I'm sure you guys have taken the average before, and that's what that is. Okay, let's try one. For trapezoid HJKL, M and N are midpoints of the legs, so they are halfway between H and L, halfway between J and K. If HJ is 32 and LK is 60, find that mid segment. So what we need to do is find the sum of the bases. HJ is that top base and LK is the bottom base. We'll add them together and then multiply it by 1/2, or we could say divide it by 2. So let's do 1/2 of HJ plus LK will equal that mid segment, MN. Let's plug in the numbers that we've got, 32 and 60. Okay, and then you might pull out your calculator for some of this. 1/2 times 92. And 1/2 of 92 is 46. Okay, so add your top base, your bottom base, and then you can multiply it by 1/2 or divide it by 2. All right, I've got one for you to try. It's a little bit different than the one we just did. This time, they gave you the top base and they gave you the mid segment. And what you're actually trying to find is one of the other bases. So you'll be plugging in your numbers in a different spot. This might be a challenge. Pause your video and give it a try, and then if you need some help, come back. Okay, let's look at that. 1/2 HJ plus LK equals MN. So we'll plug in the numbers that we have this time. HJ is 18. We don't know LK, that's what we're trying to find, so we'll leave that as LK. And then MN is 28. Okay, go ahead and try that if you didn't finish it. See if you can do it now, and if not, come back. All right, let's see. 1/2 times 18 is 9. And then 1/2 times LK, we distributed, right? Equals 28. We're solving for LK. Let's subtract 9 from both sides. 1/2 of LK, LK equals 28 times 9 is 19. Okay, that's half. Half of LK is 19, but we want whole of LK. So let's multiply this side by 2 and multiply this side by 2. 2 halves is a whole. LK equals 2 times 19 is 38. So we found a different piece that time. That was the bottom. Okay, hopefully you either got that, which is awesome, or you were able to follow along and you understand it so you could do it again, because there will be one like that on your assignment. Last part of chapter 6 is kites. Isn't that an interesting thing to have to get to study for a little bit in geometry? A kite is a quadrilateral. It has 4 sides with exactly two pairs of consecutive congruent sides. So opposite sides are not congruent. It's consecutive. It's these two right next to each other. Those are congruent. And then there's another pair over here that are congruent. So you end up with 2 next to each other and 2 next to each other that are congruent. That's what a kite looks like. And it's very much like the classic kite that we fly, in the sky. It looks just like that. These sides are congruent, and then there's usually 2 longer sides that are congruent. Couple interesting things. The diagonals in a kite are perpendicular. So if I draw this diagonal and I draw this diagonal, these 2 lines are perpendicular. And on a real kite that you fly in the sky, those would be like the braces. So it's a good thing that the braces would be perpendicular, makes them stronger. Okay, exactly one pair of opposite angles are congruent. So we don't have a lot that matches up in a kite for angles. This angle will be congruent to that angle, but these other two don't match at all. Usually this one's very, very small and pointy, and this one's usually bigger. Doesn't have to be, but these two will match, these two will not. All right, let's try this. Example 4 says, if HJ is 5 and HR is 3, that's that little line there, find RJ. Let me pull that little triangle out. So we're just looking at this piece. This is 5 and this is 3. Do you remember how we find the third side of a triangle? We need to do the Pythagorean theorem. So a squared plus b squared equals c squared. And c is always the hypotenuse, right? The longest one. I'm going to write hypotenuse. Okay, so this is our longest side. Our hypotenuse is 5. 3 can go into either the a spot or the b spot. 3 squared plus b squared equals 5 is our hypotenuse, so he gets that special spot. Okay, let's solve this then. 3 squared is 9. 5 squared is 25. Let's subtract 9 from both sides. And b squared is 16. And we don't want b squared, we want b, so we'll have to undo a squaring with a square root. Take the square root of that side. And b is 4. And b, remember, is that side, RJ. RJ equals 4. So we did it. Okay, so you might need the Pythagorean theorem when you work with kites. Let's see what this next one says. If the measure of angle A is 80, this guy's 80, and the measure of angle C is 60, find the measure of B. Okay, well remember up here, B and D will be congruent, but they didn't give us either one of those. They gave us A and C. So how can we find the measure of B and D? I think we need to go all the way back to how many degrees are in the sum of the interior angles of a quadrilateral, right? If I add all 4 of these together, what should the measure be? Yeah, 360. 360 degrees for all 4. And then if we subtract out the 2 they gave us, what's left? 360, 220. So we have 220 degrees left for B and D, and they match exactly. They are congruent. So how can we figure out what one of them is? Okay, I like that. Measure of angle B is equal to 220 divided by 2, which is 110 degrees. Okay, I've got 2 here for you to try. Take a second and come back when you're done. We'll check your work. All right, let's see. If GR equals 5, so I guess we're looking up here. GR is 5 and RK is 12. Oh, this says big long one. I'm going to draw him here. GRK. GR is 5. RK is 12. How do we find GK? So GK is the hypotenuse. He's the longest one. This time I know A squared and B squared. And C is this longest side, the hypotenuse. So what do we have? 5 squared is 25, 144. Let's put those together. It's 169 equals C squared. We'll take the square root of that. Square root of 169 is 13. That's a perfect square. Did you get 13? Okay, if you stopped right there, I'm not going to mark that wrong on a test. That one happens to be a perfect square, so we can go ahead and finish it. All right, and then the last thing, the measure of angle A is 70. Measure of angle C is 54. Oh, so we're looking at this thing again. So we've got the same kite, this time 54 and 70, but they want D. They want to know this guy. So we'll do the same thing. 180, subtract the 2, and that is equal to, 236. Okay, which is left to split between these two, and I only want the 1. So measure of angle D is 236 divided by 2, and then each one of those is 118 degrees. All right, you guys do have an assignment for 6-6, and it will be due at 9:20 the Monday after our Thanksgiving break. How awesome. All right, see you.